In this problem, we're given 4 trig functions, and we are asked to find all of the points of discontinuity in the interval 0 to 2 pi. So for example, question number 1 says if the function is tangent of x is not continuous at x values that we're supposed to list separated by commas. So let's look at these questions one at a time. Hopefully you remember that the tangent function can be written as the sine of x divided by the cosine of x. As soon as I point that out, you may realize, now that I have a variable in the denominator, that the tangent function would be undefined whenever the output of cosine of x, which is in the denominator, comes out to be 0. So if I can just list the values of x where the cosine function outputs 0, that would make this fraction undefined, and of course that fraction is the very definition of tangent. So if you remember how to use the unit circle to efficiently find values of x where cosine is 0, you may remember that for any xy pair on the unit circle, that the x value represents the output of cosine x, and the y value represents the output of sine of x. So to point something out here quickly that may not be obvious, we're using the variable x in 2 different ways in the same problem. It's important to remember that the input of any trig function is always a measure of rotation. Whereas where you see this x value here, that is not a measure of rotation. So this x, which represents the variable for the x values of points on the unit circle, that is different than the input variable x into the trig function, which is a measure of rotation. So for example, if I'm looking for where I can find a point on the unit circle whose x value is 0, that would be right here at the point 0, 1, and down here at the point 0, negative 1. So I would know when the angle is pi over 2, you get cosine x being 0, which would make this fraction undefined because you'd be dividing by 0, which makes the tangent function undefined. So although I'm saying that the angle x is pi over 2, that would be this much rotation here, starting on the positive side of the x-axis and rotating this far to pi over 2 radians. That would be x radians, or if you were in degrees, you'd say x is in degrees, and it would be 90 degrees. So part of our answer is the angle x equals pi over 2, and I got that because the x value of this point is 0. Again, we're using the variable x 2 different ways in the same problem. We do it all the time, so you must get used to it, but it's nice for me to point it out. But since the problem had us looking over the interval from 0 to 2 pi, there's one more solution. Remember, from 0 to 2 pi radians, that is one full rotation counterclockwise around the circle. And there was one more spoke on the unit circle, that's this one right here at 270 degrees or 3 pi over 2 radians, where the x value of the point is 0, meaning cosine of x comes out to be 0. Or more specifically, the cosine of 3 pi over 2 must be 0. So for the angle 3 pi over 2, cosine of x comes out to be 0, making this fraction 0, making the tangent function undefined, because there's no intelligent way to define division by 0. So those would be the answers for the first problem, pi over 2 and 3 pi over 2. And now I can move on to question 2, where they change the function f of x to cotangent of x. And the direction is the same. We are to find x values for which the cotangent of x is undefined, and we're looking over the interval from 0 to 2 pi. And notice these brackets here on the interval indicating that if x equals 0 or x equals 2 pi comes up to be one of the answers, we would report that because that's in the interval we're searching over, right? Closed brackets means we're including 0 and including 2 pi. So if you remember that cotangent is just a reciprocal of tangent, then you would know that cotangent is cosine x over sine x. So cotangent of x would be undefined whenever the sine function is 0, since the sine is in the denominator, right? If the output of sine comes out to be 0, then you'd have 0 in the denominator of this fraction, and we do not define division by 0 in math, so therefore cotangent of x would be undefined for those x values in question. And if you remember, on the unit circle, the first coordinate of the points is cosine x, and the second coordinate of any point is the output value of sine of x. So since we're looking for where sine x is 0, we will look for where the second coordinate of any point on the unit circle is 0. So you're technically solving the equation sine x equals 0 over the interval from 0 to 2 pi, including 0 and including 2 pi. So once we're on the circle counterclockwise, look for any point whose y-coordinate or second coordinate is 0. That would be this point right here has a y value 0, and this point right here has a y value of 0. So looking over the interval from 0 to 2 pi, x equals 0 degrees or 0 radians would be my first answer. And then as I rotate, 180 degrees or pi radians would be my next answer, since that coordinate is 0. So x equals pi would be an answer. And then rotating further than pi radians, I'd have to rotate all the way around the circle to get to this point again. And since there's a bracket here and here, notice I'm including both solutions, 0 and 2 pi. Even though those angles are coterminal, they represent different measures of rotation, right? Rotating 2 pi radians is much more rotation than rotating 0 radians, which is no rotation at all. So my answers for the second question are 0, pi, and 2 pi. So now I can move on to question 3, which is f of x equals cosecant x. And if you remember the definition of cosecant, it is defined to be the reciprocal of the sine function. So the cosecant function will be undefined whenever the denominator of this fraction is 0, meaning it'll be undefined whenever sine of x equals 0. Well, that is exactly the same problem that we just did. We just found when sine x was 0 over the interval 0 to 2 pi. We looked and found on the unit circle that these are the three angles between 0 and 2 pi for which sine of x was 0. So those would be the same answers as question 2. So that saved me some work. Cosecant is not continuous at 0, pi, and 2 pi. So now we're just left with question 4, where they change the function to secant of x. And if you remember the definition of secant of x, it is the reciprocal of cosine of x. So this fraction would be undefined if you were to divide by 0, and your denominator has the function cosine x. So secant of x will be undefined for all the x values for which cosine of x equals 0. And we did that in the first question of the video. The first question, f of x was given to be the tangent of x, and we wrote that as sine x over cosine x. So since cosine is in the denominator of this fraction that I've written for tangent of x, and cosine is in the denominator of this fraction that I wrote for secant of x, the answers to question 4 will be the same as the answers to question 1, which were the angles x equals pi over 2 and 3 pi over 2. Because if you're looking for where cosine of x is 0, you're looking at where the first coordinate of the point on the unit circle is 0, and that was here at pi over 2, and again down here at 3 pi over 2. So the answer to question 4 will be pi over 2 and 3 pi over 2. So those two answers came out to be the same, and these two answers came out to be the same, and hopefully you realize why.